Good evening, dear friends. And today we are going to take an interesting question from the topic of application of derivatives. And the question is written here: a circle of radius 1 unit touches the positive x-axis and positive y-axis at point P and Q. Okay, a variable line L passing through the origin intersect the circle at M and N. What is the equation for which area of triangle M and Q is maximum? So let us draw a rough diagram, and the things will become more clear. That this is the coordinate axis, okay, x-axis and y-axis, and I am drawing a circle here. This is a circle, okay. These are nothing but points P and Q, okay. A variable line passes through here, okay. This is the variable line that passes through that intersects the circle at point M and N, okay. These are the points M and N. This is point Q, and if I form a triangle from here, then it is asking that find the equation of this line such that the area of this triangle is maximum. Find the equation of this line such that the area of the triangle is maximum. So I have drawn a neat diagram on another page, and let us solve this question, okay. So it is given that the radius of the circle is 1, that means OP is of 1 length and OQ is of 1 length, and the center is at 1, 1. I don't think that it will be difficult for you to understand. Actually, if I join the point QC and CP, CP is going to be perpendicular on this line because x-axis is a tangent to this circle. Similarly, OQ or the y-axis is also a tangent to the circle. So CQ is going to be perpendicular to that line, and therefore OPCQ is a square, and therefore OP will be equal to this radius and OQ will be equal to radius. So C is 1, 1. These are the things of simple geometry that you have learned in class 8th and 9th. So I am not going to discuss it. Now let us first of all focus on the equation of the circle. How I am going to write the equation of the circle? So the equation of circle is x minus 1 whole square plus y minus 1 whole square is equal to 1. I think it is clear, okay. 1 square, or I am simply writing 1 because square of 1 is nothing but 1. Now the equation of a straight line is y is equal to mx. So if I want to find the point M and N, capital M and capital N, then I need to solve these two equations simultaneously. I have repeatedly said this concept in the class. So let me write like this: x minus 1 whole square plus mx minus 1 whole square is equal to 1. Now why I am doing all this? The broader strategy is this, that I will find the length of Mn, I will find the length of Qt, and then 1 by 2 into base into height, I will get the area of the triangle MQN, and then I will see that how to maximize it, okay. So the current thing that I need is to find the length of Mn. So if I will simplify it, what I will get? X square plus 1 minus 2x plus m square x square plus 1 minus 2 mx is equal to 1, right. Now x square into 1 plus m square, 2x m plus 1 plus 1 is equal to 0. This is a quadratic, and from it I can find the length of M and N. So before it, let us first of all talk about the coordinates of M. So if M has x coordinate x1, then what will be the y coordinate? We can say that it will be mx1, because these lie on the line y is equal to mx. Now if I say for n the x coordinate is x2, then the y coordinate is mx2, right. Now if I want to find the length of Mn, so I will be needing the sum of roots as well as the product of roots. Why? Because to find, okay, first of all let me write here the product and sum of roots. So the sum of roots, let us say that it has two roots x1 and x2, then x1 plus x2 will be equal to minus b upon a, or twice of m plus 1 upon m square plus 1. Similarly, if I want to find the products, it is nothing but 1 upon 1 plus m square, right? Now coming to finding the distance mn, because I want to find the length of mn. So if I want to find the length of mn, what I have to do is square root of x1 minus x2 whole square plus m square into x1 minus x2 whole square. Okay, now from here I can write it as mod of x1 minus x2 square root of m square plus 1. Now I want to find the difference of the roots, and the difference of the roots can be found easily by if we know the sum of roots as well as the product of roots. So I know the sum of roots and product of roots. Now I can use them to find the difference of roots, and that can be written as square root of x1 plus x2 whole square minus 4x1 x2. Okay, this will give me x1 minus x2 whole square and root under m square plus 1. So if I substitute the values, then I will be getting twice of m plus 1 upon m square plus 1 whole square minus 4 upon 1 plus m square into root under m square plus 1, right? Now I can write like this: m square plus 1 whole square, and this will be 4 m plus 1 whole square minus 4 m square plus 1 times root under m square plus 1. So if I simplify it, I will be getting it like this: 4m square will get cancelled, 4 and 4 will get cancelled. The only term that will remain in the numerator will be 8 times of m, and in the denominator this will get cancelled with that, and finally only one power will remain. Okay, because if it will come outside, then it will be simply m square plus 1, and divided by it will be root m square plus 1. That's why this is. So this is the length of mn. Now I also need to find the perpendicular. So in the question I can see that the perpendicular is qt. Okay, so how to find the length of qt? The point q is known, 0, 1. The equation of line is known. So qt can be easily found as, qt can be written as 1 upon root under 1 plus m square. I hope you might be knowing this by the formula of perpendicular drawn to a line. So coming to the question, now I want to find the area. I want to find the area of the triangle. What I want to find? I want to find the area of the triangle. Okay, so for area of the triangle, let me denote it as delta. So area can be written as 1 by 2 into base into height. Okay, so base is this thing, root under 8m by m square plus 1, and the height was 1 upon root under m square plus 1. So this is the area, that is delta. Okay, so upon simplification it will give me 1 by 2 into 2 root 2 into root m upon m square plus 1. Okay, so 2 get cancelled. This will be root 2 times m to the power 3 by 2 plus m to the power minus 1 by 2. Okay, this I got as delta. Now if I want to if I want to maximize this, that means I can achieve it by minimizing the denominator. So how to minimize the denominator? This is a function of m. So for minimizing the denominator, I can write it like this: d delta upon dm should be equal to 0, and then I will be proving it that it represents the minima. So first of all, no, d delta not, actually I have to minimize the denominator. Okay, so let me say that this thing is p. Okay, this thing is p. So if I take out dp by dm is equal to 0, then it will give me 3 by 2 times m 1 by 2 minus 1 by 2 times m minus 3 by 2, and that should be equal to 0. So this will give me 3 root m is equal to 1 upon m root m. Upon multiplication, I will get m square is equal to 1 upon 3, or m is equal to 1 upon root 3, not minus 1 upon root 3. Why? Because it is given that the line is in first quadrant. Okay, the line was in first quadrant. See, so its slope is going to be acute angle, and therefore I am taking the slope as only m is equal to 1 upon root 3. Okay, not minus root 3. So now I got the slope of the line. So can I find the equation? Yes, y is equal to mx was our equation. So if I substitute in place of m as root 3, 1 upon root 3, then the equation is y is equal to 1 by root 3x. Is the question finished? No, because we also need to prove that for m is equal to 1 by root 3, it represents minima. So how I can get it? See, if I again differentiate it, that means if I do the double differentiation, if I calculate the double differentiation, then if it is greater than 0, that means it represents minima. So see what it will give: 3 by 2 and into 1 by 2 and m 1 by 2 minus 1. Okay, that means m minus 1 by 2 and plus 3 by 4 m minus 3 by 2 minus 1. Okay, so m minus 3 by 2 minus 1 will be equal to m minus 5 by 2. And now see, both of these I have got this as the double derivative, that means this is d square p by dm square. Okay, if I substitute the value of m here, if I substitute the value of m in this equation, it is going to be greater than 0. Okay, because there are no any negative terms, only they are in the power, and when it will come in the denominator, it will be positive. That means d square p by dm square is greater than 0, and therefore it represents minima, and therefore this point represents minima. You actually don't need to check this in such questions, because it is always true that it represents minima or maxima, whatever is required in the equation. Therefore the answer is y is equal to 1 upon root 3x. So this was a good geometrical problem, a bit calculative, and I hope you would have enjoyed this question. Okay, so this was our question. I hope you would have enjoyed this question. So please leave the comments in the comment section, so that inspires me actually to make more videos. Thank you.